I thought this was useful to show. This is actually a fully contained data center and an airflow model and what a contained data center looks like. And we're going to talk about some of the ways to get here, but essentially all we're doing is isolating the airstreams. We're isolating the cool air supply and the hot air return. And we're expecting on all these examples that there is about a 3% leakage performance from that cold to hot, meaning about 3% of the space is open between the barriers, and it is leaking 3% of the air. So if I'm supplying 100% on a demand, on average, 100 CFM, on average, I'd expect we need to supply no more than 103 CFM to keep that kind of demand up. So again, isolation of the airstreams is really what's going to drive the predictable system. I can tell you what's going to happen in this type of system when you increase load, decrease load, create more leakage, add another cabinet. All of it is very predictable in this type of system, what's going to happen. So what types of containment are there? Let's just cover that 30,000 foot view of containment. Well, there's cold aisle containment, hot aisle containment, and rack-based containment. Those are the three general types of containment that you're currently looking at. And really, you can implement those, any one of those models in two ways. You can do partial containment, which there is some benefit to partial containment. Remember that? Managing the supply delta T and the return delta T, you can focus your containment strategy on either one of those and get partial containment and partial benefit. Or you can do total containment and completely isolate the airstreams and capture your full entitlement that's on the table. And then two methods for implementation exist. Some of the things that you're seeing here is containment that's integrated to the rack. Means I'm actually out there with a screwdriver and a wrench and I'm bolting this stuff to the racks. Right? That's integrated to the rack. Or independent to the rack. Meaning I don't know what kind of racks I'm going to have, or I'm a colo and I don't know what racks will come in next week, next month, next year. Or I'm in a high change environment, and I may change my racks from time to time. So you wouldn't want it physically bolted to the rack, so you could have the freedom to make that. So as far as the methodology, and we'll cover the different versions and what some of the trade-offs are between the different types of containment. But be aware, there are trade-offs for all of them. Right? We're not going to walk out of here with a silver bullet. We're going to walk out of here with an understanding. So what is the best containment for my data center? Well, things to consider when you're trying to select a containment strategy. Are you working on a new facility or an existing build? Because that has some limitations, and right away you could probably eliminate some if you're an existing build. The containment system is an integral component of your overall HVAC design. So your HVAC system needs to be able to handle the higher heat that's coming back, and the airflow patterns need to be able to be matched up. And then, of course, thermal ride-through is another concern. A lot of legacy data centers rely on the amount of air mass in the data center to be their thermal ride-through. And then how the evolution cycle of the IT equipment is executed. Do I come in once in a while and replace one server, one rack, a row of racks, an ERP system? How does that evolution happen? All that has some impact on how that's going to be executed and what type of containment you want to select. And of course, how often that happens. If it's a set it and forget it data center, well, you have some different options. And then the uniformity of the equipment rows. Really love to go into a data center and install a containment system where I see row after row and they're all nice, even, same rack. Real straightforward to think about a containment system that way. However, that's not what all data centers are like. They can be very disjointed. They could have spaces in the rows, not unusual. Maybe not even set up in a hot aisle, cold aisle. That's still something that is being adopted in the industry. All that has some impact. And then, of course, the usage of rack. Everything I've been talking about is a rack, but there is a significant amount of high-density consumption going on in non-rack-based equipment. You want to try to capture that heat as well. And, of course, obstructions in the environment. You can see some of these pictorials, you can see some overhead obstructions. That creates issues for a containment adoption, particularly in an existing data center. And then the last, which I'll actually cover here later, is the human behavior in the data center. Remember I was talking about the amount of entitlement that you have versus the amount of efficiency that you actually capture. That's a balance between your efficiency entitlement and your efficiency attainment. Two different things, and I'll explain. So some of the trade-offs. The amount of cool air in the data center, the comfort of the IT staff in the working environment, the process adherence for best practice and maintenance of that data center going forward, the efficiency difference between the different methodologies, and the efficiency entitlement versus attainment, and of course fire suppression and detection, a safety consideration. So the way I look at this, as far as the thermal inertia, well, in a cold aisle, the only cold air I've got is just in the cold aisle. I really don't care how I get it there, from overhead supply or underfloor. Really, the only cold air is in the cold aisle. And as I look at the hot aisle, well, the rest of the data center is actually cool, and just the hot aisle is hot. And then, of course, rack chimney, all the heat is in the chimney, and the entire data center is cool air. All of those provide more thermal mass, and the assumption that it's a better ride through. And if I calculate that out in the amount of cubic feet, yeah, the rack chimney does win out, but one of the things you want to consider is the total air consumption of the high density data center, which is probably what's propelling you into a containment discussion. You need to be thinking about something else other than the amount of thermal mass stagnant in the room to support your data center through an outage. At these types of data centers, you want to be thinking about a dedicated thermal ride-through strategy, and that would include UPSs on your fan motors, stored chilled water if you're running a chilled water system, to carry you during an outage and a startup. So although the rack chimney provides the most amount of cool air for thermal mass, I'm not sure that's a critical criteria for decision making, but it is winning out by a slight margin. Comfort factor for the IT staff. Well, plain and simple, the cold aisle is definitely comfortable to work in, but not a lot of the work happens in the cold aisle, unfortunately. The hot aisle, it's where all the networking connectivity is, and server activity for the most part is happening in the hot aisle. Temperatures can get not unusual in a contained environment to see 100 degrees in there, depending on what you're running your equipment at, but a delta T of 20, 25 degrees is not unexpected. So that 100 degrees is pretty hot. And in the rack chimney, well, the entire data center is a consistent temperature on the supply side. But when you open up the door to go work on that same IT equipment, chances are you're going to be faced with a warm air plume, a hot air plume out into the data center and into the IT tech. So again, no silver bullet here as far as the comfort goes. Some of the trade-offs we'll talk about early as far as what happens when the IT tech is uncomfortable. But as far as efficiency capture, and one of the things you'll notice is the consistency. I can run any type of CFD or actually testing methods that says, yes, if I achieve total isolation from hot to cold, it doesn't really matter what kind of containment I have, whether it be hot aisle, cold aisle, or chimney based. Going from a legacy design, you're all in the same band of your entitlement for your efficiency. One of the other things to think about capturing that efficiency, you're doing it with as little or few parts as possible. And obviously, the cold aisle and the hot aisle is an aisle structure, meaning end of row doors, a ceiling, maybe some ducting to get into there. A lot of physical components. Yes, they can be engineered and designed to work together, but when you're trying to contain something like air under pressure in volume and velocity, the less parts typically, the better that is. And that's the only point that I'm making here between the different efficiency capture methods. Now, one of the things that you want to be aware of is, yes, containment can be relatively straightforward, and yes, you can get the efficiency benefits between the different types of containment, but there's one common denominator that will destroy all your benefits for any type of containment that you're possibly looking at. And that's what we call rack hygiene. I can't tell you how many containment systems that we put in, and we can talk about that entitlement by looking at the demand of the data center. And then when I start peeling the onion, I look at the rack hygiene. The rack hygiene is typically poor in a legacy data center, getting better as some of the new rack designs are coming out that are thinking about the airflow management in a rack and creating that front-to-back barrier in a rack. But as you can see in this example, which I've purposely made worse to show the point, but essentially what we're looking at is if I completely load up the U space of a rack and I completely blank that off, and that's where all the supply air is going, well, the 5 leakage areas are still losing a lot of cool air, and if cool air can go through these areas, warm air can come back out. And you're only talking about a pressure difference to make that happen. And then you've lost your containment integrity. Now, one of the things we like to talk about for all these different 5 fault areas is we say 60% of the air leakage can be from the rack. Meaning, as I look at a contained solution, and I look at the amount of square footage in either a hot aisle, cold aisle, rack-based containment, I don't really ever go below 60% of the amount of square area that needs to be sealed off has to do with the rack. So I can provide that 3% leakage in a aisle containment system. If you have really bad rack hygiene, well, if I'm trying to average out 40% of the square footage at 3% leakage and 60% of the square footage at 50% leakage, well, you're not really going to capture much of the benefits. Right? So, and you're trying to capture the efficiency. Right? So that's one of the things we like to talk about is rack hygiene and looking at these the under the rack component. And this is obviously showing a raised floor type design, but air that actually goes underneath the rack. Racks that are sitting on casters or standoffs can present anywhere from a 1 to 2 inch gap underneath the rack, and that's where a lot of air can escape, and it'll go right past your front to back barrier. The left and right hand side of the rail, although this can be closed up, needs to be a lot of access capability there. This can be closed up with brush strips or other type of sealing grommets, but as you go around the rail, and one of the things that's happening nowadays because of the wider connectivity demands of racks and IT equipment, they're going to wider racks. Right? You're moving away from that 19-inch, 4-post rack to the 24, to the 28, to the 30, to the 36. And as you look at some equipment demanding a 40 with 19-inch rails in the middle, think about how much space is left over for air to be whizzing by. So left and right-hand side of the rails are a concern. You need to really be thinking about what is the wire management demand and sealing that off. And then lastly is above and below the top and bottom U space. It's not unrealistic to have common frames with different size rails inside a rack, such that if you put 48 U rails inside an overall cabinet frame that could support up to 51 U, you're going to have space above and below the top and bottom U space. That's not even an opportunity to put in a blanking panel. That can be leakage areas as well. You want to make sure that those areas are closed off. And again, what we're trying to do is one, seal the front to back so there's no more than 3% leakage front to back when the entire U space is consumed with IT equipment.